In this lesson, we're going to take a closer look at the package mechanism. The Java distribution has several thousand classes, and packages at their simplest are a way of grouping related classes together. This helps us to know where to look when trying to find functionality, and avoids us having to look through lots of irrelevant classes at the same time. Packages also define something called a namespace. A namespace is like a family name. At home, I might refer to my children by their first names, but in school, if I called one of them by name, 5 children might turn around. So I could use my family name as a way of reducing the confusion. Similarly, a class has a full name that consists of the package name and the name of the class. I can refer to a class using that full name at any time if I choose to. But much of the time, there's no name conflict, and I can get away with just using a short name. Let's look at an example. Here's a project called Packages. It has a main program file called packages.java, and that's the main method there that will start the code running. Let's take a moment to look at the Java API documentation. In the package java.util, here, we find a date class. This is a long-standing class that represents a date. Much of what it does has been superseded by another class called calendar, which knows all sorts of international calendars, but the date class suits our purposes well. I can refer to the date using its full name, which is java.util.date. And if I simply create an instance of it and print it out, let's put that code in here. Java.util.date today equals new, java.util.date. And then I can print the fellow out. I'll make sure it's saved and run that. And it says, today is Friday, June 1st, blah, blah, blah. So we can see that it does something potentially useful. But using the full name of this class, this is sometimes referred to, by the way, as the fully qualified name, is rather cumbersome. It involves a lot of typing. It turns out that I can invite this class home and start just using the short name. This is like inviting one of my children's school friends home. I wouldn't use my children's full formal names at home, and I wouldn't use the full names of their friends either. Because I've invited them in, then as long as there's no obvious confusion, that is, they're not both called Jane, say, then the short name works well. So, to invite this class home, I have to tell the compiler about the invitation using this construction. I'm going to put this just in here. I say import java.util.date. This must be placed right after a package statement in the source file and before any class definition in that file. I can put multiple import statements in the file too. I'm not restricted to just one friend. Having done this, I no longer have to refer to the date class using its fully qualified name. I can use its short name. So I can change the variable type and the constructor to just use date, like that. Date today equals new date. And if I save it and run it, everything behaves exactly the same. Let's try deleting that import for a moment. So we'll take this and we'll cut it out. Notice the compiler is now complaining. If we hover over here, it says cannot find symbol for class date. There are actually several ways we could fix this. We could manually replace the import statement that we just deleted. But you'll find there are lots of classes you'll be using from other packages, and this manual typing can become tedious. So NetBeans has some suggestions. First up, we'll go to the Source menu, click on that, and find Fix Imports. NetBeans can create the imports we need. In this case, however, you'll notice there are actually 4 classes in the system called date, and it's not clear which of those date classes we're referring to. NetBeans has actually made a guess because it saw us using this one just a moment ago. But this is as though there's more than one class at school with the name date, so we have to help NetBeans out by telling it which of these imports we want. So we'll choose java.util.date and we'll click OK. Notice it puts the import back for us. And that, of course, was the original point of the package and import mechanism. It allows us to deal with potentially conflicting naming. There are several date classes, each with different intentions. Because each lives in a different package or a different namespace, we can distinguish them, and yet, by using the appropriate import, we can write code that is concise. So when you use classes from other packages, whether those are packages you created or packages from libraries, you'll generally need to provide the import statements that resolve the fully qualified names of the classes that you're using. That raises an interesting question. We've used the string class, but we haven't ever imported it. That's because the java.lang package, which string belongs to, is treated as everybody's friend, so you never have to import any of the classes defined in it. Finally, you can create packages of your own to partition your own work. That's pretty easy, and NetBeans does most of it for us, though it's worth looking at the Java syntax that it creates to achieve this. Let's open up the packages project, and we'll find here the source packages element. Right-click on that, select New and Java Package. Give the package a name. By the way, package names should be entirely lowercase. So we'll call this Other Package, and then click Finish. Notice it created this other package here. These things are pictures of a brown paper parcel tied up with string. This one shows that it's empty by being gray. Now we can right-click on the new package and select New Java Class. We'll create a class here and we'll just call it My Class. Notice the naming convention for classes says that they should start with an uppercase letter as well as use an uppercase letter at the join in words. We'll click Finish. And now Other Package isn't empty any longer. We've got our class that's actually in there, and here we see the skeleton that's been created for us. Notice that right at the top of this skeleton there's this statement, Package Other Package. Turns out that's what puts this class in the Other Package package. From a syntax perspective, that's all that's needed. It's also true, though, that the source and binary files for this class must be located in a directory with the same name. But NetBeans has taken care of that for us. We'll give this class some minimal behavior just so that we can see that it's real. I'm going to add a toString method to it so that it can print something out when we ask it to. Then we'll go back to our main program file and we'll add some code here to do something with this. So we create a class, MyClass, and we create a variable to refer to it, and we ask to print it out. But notice that the compiler is complaining, cannot find symbol MyClass. The point here, of course, is that it needs an import. We could do this the same way as before, but notice the little red blob here on the light bulb icon. Click on that and see that it offers us the option for Add Import for otherpackage.myclass. So we'll click on that and it does precisely that and puts it up here. So that's another way of fixing a single import. You can choose whatever method you prefer. So there we have it. This lesson has looked at the significance of the package in Java, the use of import statements to allow us to use short names for classes, and how we can create our own packages and put classes into them.